let's look at graphing quadratic functions in the form f of x equals ax squared plus bx plus c. Remembering f of x is the same as saying y equals. So in example 1, let's look at f of x equal to x squared plus 4x minus 5. Notice we're not in vertex form. So what we want to do is get this quadratic equation into vertex form. And the way we can do that is by completing the square. So remember, in completing the square, we wanted our quadratic and our linear term together. We wanted to get rid of that negative 5. This time, we're just going to create a space after that linear term before the constant term. Now we're going to complete the square with just the x squared plus 4x. Remembering, we're going to take the linear coefficient, 4, we're going to divide it by 2, and then we're going to square it. So 4 divided by 2 gives us 2, squared gives us 4. So we're going to add 4 between the linear and that constant. In order to combat that positive 4 that we've added to our equation, we're going to also subtract from the end that negative 4. So then our new equation, or function, is f of x equals x squared plus 4x plus 4 minus 9. We're going to go ahead and factor the trinomial x squared plus 4x plus 4 that we just completed the square for. So we have x plus 2 squared minus 9. Remembering, this 2 came from what we got from what was in the parentheses after we divided it by 2. Now we're in the form a times the quantity x minus h and parentheses squared plus k. So this gives us our vertex and our a value. So our vertex is going to equal, remember we're taking the opposite of what's with the x, so negative 2, and then the outside number gives us our y value, negative 9. Our a value is a positive 1. Remembering, there's a 1 out here if there's not a number listed. So in order to graph this on my coordinate system, I can go to my vertex, negative 2, negative 9. Place my vertex. My a value is positive 1, so I know it opens up. And I also know that it has the same form of just x squared. So I'm going to come over 1 and up 1 in both directions to get to my next point. And I can draw in my graph. The last thing we want to go ahead and label is my domain, my range, and also the end behavior. Domain, remember, is the x values. So in here, my x values, I can go from negative infinity all the way to positive infinity and see my graph with x values. So my domain, we say, is negative infinity to infinity. My range, my y values, well, since my graph goes up in both directions, I'll be able to say everything up in here is included in my range until I get down to this point. And this y value is negative 9. So my range begins at negative 9 and it goes to infinity. Remember, we used the bracket to say that we can include negative 9 because we can come all the way down to negative 9. We use the parentheses for the infinity sign because we cannot touch infinity. My end behavior talks about what happens at the end of each of my curves. Well, notice here, this is pointed up and this one's pointed up. So my end behavior, we say, is up and up. And now we've just graphed our first quadratic equation in ax squared plus bx plus c form. In example 2, let's look at an example that has an a value, or that will end with an a value. So in example 2, let's say that f of x equals 2x squared minus 12x plus 19. We're still going to complete the square. So we're going to move this 19 over slightly. But we're also going to factor out this 2 out of the first two terms. So we have 2 times the quantity, x squared minus 6x. Then we're going to leave a space, and our 19 is going to go at the end. Inside the quantity, we're going to complete the square, as we did before with the negative 6. So we're going to take negative 6, we're going to divide it by 2, and we're going to square it. So negative 6 divided by 2 is negative 3 squared gives us 9. So we're going to add 9 inside that quantity. But we're not actually adding 9 to this function. If we were to distribute this 2 through, we'd have 2 times 9, which is actually 18. So we're adding 18 to this entire function. So to combat that positive 18, we're going to subtract 18 off the end. Simplifying this, our function now becomes 2 times, we're going to factor x squared minus 6x plus 9, remembering that it factors to x whatever this number is in the quantity, so minus 3 squared plus 1. Now we have it in vertex form. So my vertex is equal to the point opposite of what's with x, so 3, and then the number on the outside. My a value in this case is a positive 2. So now I can make my graph. My vertex, 3, 1. So I'm going to come over 3, up 1. My a value in this case is 2. So to get to my next point, I'm going to come up 2 and over 1 in both directions. Remember that if our a value is a positive, it's going in the upward direction. But also that 2 tells us how wide or skinny this graph is. The larger this number, the skinnier the graph. The smaller this number, or the more fraction it is, the wider it becomes. The last thing we want to look at is the domain, the range, and the end behavior. My domain, any x value can be placed into this function. I can also look at it graphically. This graph goes up forever and in the outward direction, so I can always start at my x-axis and go up and touch that graph. As I go along the x-axis out to positive infinity, I can also go up and touch that graph. So my domain, we say, is negative infinity to infinity. My range, however, if we start down here at negative infinity, my graph does not come down this far. It doesn't start until we hit the point of 1. From 1, we can always go on the y-axis and go over and touch this graph. So we say the range starts at 1, we use a bracket because we can touch 1, and it goes to infinity. My end behavior, we start high and we end high. So we have an up arrow and an up arrow. And that finishes the problem. So we've been able to graph it, state the domain, the range, and the end behavior. Example 3 Since we've looked at two that open up, let's look at one that does not open up. It actually opens down. So let's look at f of x equals negative 2x squared minus 12x minus 22. We should already see that we start out with a negative, so that should tell us that something else is happening with this function. We're going to start the process the same. We're going to factor out that negative 2 out of the first two terms since we have a leading coefficient. So we have negative 2 times the quantity x squared plus 6x, leaving a space, minus 22. Take the linear term, divide it by 2, and square it. So we have 6 divided by 2 is 3, squared gives us 9. So we're going to add 9 in that quantity. If I take that negative 2 and distribute it through, I'm actually subtracting 18 off of this equation. So to combat that negative 18, I'm going to add 18 to this side. Factoring the trinomial and simplifying my constants, I now have f of x equals negative 2 times the quantity of x plus 3 squared minus 4. I now have it in vertex form. So my vertex is equal to negative 3, negative 4, again the opposite of this positive 3, and my a value is equal to negative 2. Graphing, I'm going to start at negative 3, negative 4 for my vertex. My a value is negative 2 this time, so I can go down 2 and over 1 in both directions. Notice our parabola opens in a downward motion this time. Finally, my domain, range, and end behavior. My domain, again, we can start at negative infinity on the x-axis and go down this time, and will eventually touch this graph. As I work my way across the x-axis, I'll always be able to go down and touch this graph at any x point. So my domain is negative infinity to infinity. My range, if I start from negative infinity and go across on the y-axis, I'll be able to touch the graph as well. And I'll be able to do that all the way up till y equals negative 4. So in this case, my range is negative infinity to negative 4. We're going to include negative 4 with the bracket. My end behavior, I'm in the downward direction in both sides of my parabola. Let's go ahead and look at one last example. Example 4. F of x equals negative 3x squared plus 4x minus 5. Notice we have a leading coefficient that's not 1, and we have a quadratic form in standard form. So we're going to go ahead and complete the square. First, we're going to factor out that negative 3. So we have x squared minus 4/3 x, leaving a space, and your quantity minus 5. Remember, if we take 4 and divide it by a number, we can just write it as an improper fraction. This problem becomes a little more complicated because we do have that fraction to deal with, but we've done it before. So let's take 4/3 off to the side. Let's divide it by 2 and square it. Remember, to divide a fraction by a number, we can simply take that denominator of our fraction and multiply it by what we're dividing it by. So we end up with 4/6 squared. 4/6 we can reduce to 2/3, and if I square 2/3, I end up with 4/9. So I'm going to add 4/9 to this side. If I take 4/9 and multiply it to my a value, negative 3, Again, off to the side, we'll take negative 3 times 4/9. We make negative 3 as a fraction by placing it over 1. So we end up with, canceling our 3 and our 9, because 3 goes into both of them, we end up with negative 4/3. So we're actually subtracting 4/3 in this area. So to combat that, we're going to add 4/3 to the end. Let's go ahead and factor this trinomial. So we end up with negative 3 times the quantity, x minus, again, if we take the number that's in here with our minus sign, we get minus 2/3 squared. And we need to take negative 5 and add 4/3 to it. If we look at negative 5 in thirds, we have negative 15/3. So negative 15/3 plus 4/3 gives us negative 11/3. And there's our function in vertex form. So my vertex can be written as a positive 2/3, remembering that we're taking the opposite of what's with x, and the negative 11/3, the last number. Our a value, in this case, is negative 3. So let's go ahead and look at what the graph of this looks like. Here we're going to start at the positive 2/3, so I'm going to make my units just a little larger, and then negative 11/3. If we think about negative 11/3, that's going to be negative 3 2/3. So I'm going to come down So I'm coming over 2/3, so approximating, and coming down negative 3 2/3. So we're approximately in that area. Our a value is negative 3, so I'm going to come over 1 unit and down 3 units. In the same manner, I'm going to come over in the negative direction 1 unit and down 3. Remembering that these points are going to be mirror images or reflective of each other. And there's my graph. Now we can talk about our domain, our range, and our end behavior. Domain, again, at negative infinity on the x-axis, we could go down and touch this graph eventually. And as I work my way across the x-axis, I'll always be able to go down and touch the graph at a certain point. So my domain, we say, is negative infinity to infinity. The range is talking about the y values. So we're looking on the y-axis, and as I'm down here at negative infinity, notice I'll be able to touch it in 2 places down here. As I work my way up the y-axis, I'll always be able to touch it going across until I hit this point of negative 3 2/3 or negative 11/3. So my range, we're going to start at negative infinity and we're going to end at negative 11/3. We're going to use a bracket because we can touch the negative 11/3. We use the parentheses again because we cannot touch the infinity. Our end behavior, we start at the negatives or pointing down, and we end pointing down. So our end behavior, we say, is down and down. And there is graphing a quadratic equation in standard form.